In the last video we had discussed about the spectrum and various region we have observed, and that for each region have their own frequency and wavelength and uh, energy also. So in the first video we had discussed about the region of it, that how one can get the electromagnetic radiation and how one can define that. So we had discussed two regions, radio frequency region and microwave region, and the third region is the infrared region. Third region is known as the infrared region, and the frequency range of the infrared region lies from 3 into 10 raised power 12 to 3 into 10 raised power 14 hertz, and the wavelength is 100 micrometer to 1 micrometer. This is wavelength of this region, right? So, and this is the frequency range, and if you calculate the energy of this region, that is basically of the order of 10 raised power 4 joules per mole. This is the fourth region in the spectrum, that is visible or ultraviolet region, and the frequency range is of the order 3 into 10 raised power 14 to 16. Yes, so hertz, and the wavelength is of the order of 1 micrometer to the 10 nanometer. Hundreds of kilojoule per mole. X-ray region. The frequency range of X-ray region is 3 into 10 raised power 16 to 18 hertz. This is 2 10 raised power 18 hertz. This is the frequency range, and the wavelength is 10 nanometer to the 100 picometer. This is the wavelength, and energy order is of 10,000 kilojoules. Gamma ray region. In gamma ray region, one observed the frequency of the emitted photon is of the order of 3 into 10 raised power 18 to 10 raised power 20 hertz. This is 20 hertz, and wavelength is of the order of 100 picometer to the 1 picometer. This is the wavelength, and energy is of the order 10 raised power 9 to 10 raised power 11 joule per mole. This is the energy range. So by this way you can remember these 6 region. First is R, radio frequency region. Second is microwave region. Third is infrared region. Fourth is visible or ultraviolet region, and fifth is X-ray region, and sixth is gamma ray region. So RMI Vx gamma, you can remember by this way, RMI Vx gamma, and the frequency range, how you can remember, It basically started from 3 into 10 raised power 8 to 10 raised power 3 into 10 raised power 6 to 10 raised power 10 hertz, and wavelength was started highest longer wavelength 10 meter to 1 centimeter by this way. And now you 10 raised power 10 to 10 raised power 12, 12 to 14, 14 to 16 by this way, 16 to 18, 18 to 20. You can keep remember by this way the frequency range. So here 18 to 20, in earlier case 16 to 18, and similar to earlier one, same. And on the same way you can keep remember the wavelength and the energy of the emitted photon. Wherever you observe the change of spin, you will get the radio frequency region. So in nuclear magnetic resonance and electron spin resonance, what happens here? Nucleus spin changes. On the other hand, in electron spin resonance, electron spin change. If somehow you change the orientation, when you change the orientation, that time you observe the microwave region. Suppose orientation first is this, and after some time it becomes this one. So by this way you observe the change into the orientation. When this happens, one can get the microwave region in molecular spectroscopy. Third point is change of configuration. When change take place into the configuration, then that time one observe the infrared region, the like this one. So in infrared region, basically these atoms change their configuration. And X-ray. So these two are the result because of change into the electronic distribution. If suppose one electron jumps from this cell to this one, or this cell to this one, then we see change into the electronic distribution. And similar same thing happens with the X-ray. So the ultraviolet region and X-ray region we obtain through the change into the electronic distribution. And if the last region, last cause, if change occurs into the nuclear configuration, so if change of nuclear configuration, then we observe the gamma rays.